Hello everyone, welcome to this training. This is Asia, responsible for the DENAIR Dry oil-free screw air compressor. I will be explaining the product to you all in the following time. Part 1. About ISO 857391-2010. This standard specifies the quality requirements for compressed air, including dirt, water, and oil. First, this column specifies the classification of levels, class 0 to class 9. Class 0 is the highest level. Oil-free compressor of DENAIR is class 0 for oil content. But content of dirt and water need the post-pressing device to remove. This diagram is a relatively comprehensive flowchart of the system, including air compressors, filters, and post-treatment equipment. This page displays our two oil-free certification. This highs the oil quality in the industry, and all products are tested and certified by German authorities. Part 2. Application of oil-free compressors. Which industries can utilize oil-free compressors? For example, food and beverage. In food processing, carbon dioxide is added on specific beverage pressure during production to enhance the taste and texture of drinks. Automobile, car spray painting, and washing services. Chemical, participate in chemical reactions and complete air delivery. Pharmaceuticals, carbon pharmaceutical raw materials and finished products. Electronics, prevent contamination of semiconductor materials. In addition to the industry's machine above, such as the high-end textile industry, prevent contamination of yarns and textiles. The oil and gas industry, the specific requirements will about depend on the customer's needs. Part 3. DENAIR oil-free screw compressors. DENAIR's product models have dry oil-free screw air compressor, DWW series fixed speed, dry oil-free screw air compressor, DWW series VSD. The DWW series can adjust the airflow rate according to actual air compression. The main components list of the DENAIR oil-free air compressor include the air end. The GHH brand is from Germany, and the DENAIR brand is from China. Motor is from China, but other well-known brands such as ABB and WEG can also be selected. Bearings SKF is from Sweden. The electronic control system adopts Schneider, a brand from France, and the air filter and oil filter is the DENAIR brand from China. The sensors from France and the invent only VSD models have invent. Invent is the latest company in China and the second leading brand of French inventors. For the controller adopted Pratt, a domestic brand, CMC and Siemens PLC are also applicable. Part 4. PID diagram. Next, I will briefly introduce the working process of an oil-free air compressor. Firstly, air line. Atmosphere air through an air filter. Filtration is applied to remove fine dust for the protection of the air end. Enters the air intake valve. can be control the loading and unloading of the air compressor, then enters the first stage air end. The first stage compresses the air, which then passes through a water tube for stability follow and reducing noise and flexible house facilitates the connection of two sections of metal pipes into an intercooler in order to reduce the exhaust temperature of the first stage air end, and then into a water air separator. Drain the water separated from the first stage air end. After separating the moisture from the compressed air, it enters the second stage air end, where it is compressed to the target pressure and then discharged. It then passes through another ventral tube and flexible house into a aftercooler. After cooling, the compressed air is discharged. This part is used for drainage through the relief valve and discharge. Second, oil line. The oil pump drains from the air and the oil tank. The oil then passes through a temperature control valve, which checks if the oil temperature is too high. If the temperature is within the normal range, the lubricating oil passes through an oil filter and then to distribution block. If the oil temperature is too high, it first passes through an oil cooler for cooling, and then, after cooling, and passes through the oil filter. After filtering out the dust in the oil, it reaches the diversion block. The diversion block then distributes the oil to the areas requiring lubrication, the gearbox, the air and the bearing and the gears, and the oil cooling jacket, thus forming a complete oil circulation system. By the way, why does an oil-free air compressor still requires lubricating oil? Because the oil only lubricates the components that need lubrication and doesn't participate in the compression process, with no oil present in the compression chamber. This is a detailed PID diagram. This is oil line. This section's language distribution is consistent with what was presented earlier, but the content is similar. Part 5. Components. What components make up a complete air compressor? I will explain this in detail in the following sections. Air filter, one of the maintenance parts. The first maintenance period is 500 hours. Adopt dry pipe with a filtration accuracy of 5 micrometers and effectively of up to 99%. The suction box of the air compressor is independent. The special design ensures that the compressed air sucked in doesn't contain dust or mist, ensuring the cleanliness of the air. Thanks to its unique design, it results in lower intake noise and cleaner air. Next is the oil filter. The oil filter is also one of the maintenance parts. The first maintenance period is 500 hours. Its accuracy is 10 micrometers to filter out impurities in the oil system to prevent foreign matter from entering the main air ends, gears, etc., causing wear or jamming. The oil mist separator, one of the maintenance parts. The first maintenance period is 500 hours. High filtration accuracy and efficiency. Less than 1 ppm. Efficiency is 99.9%. High quality material, ultra fine glass. plus oil-filled paper. Maximum operating temperature is 120 degrees. Its main function is collecting the oil mist generated by high temperature and recycled into the oil tank, effectively preventing the reduction of lubricating oil amount. To reduce the risk of dust oil mist mixing into compressed air and ensure air cleanliness. It also plays a role in protecting the environment. Air intake valve. Its main function is drawing air, control loading and unloading. It uses a diagram-type pneumatic mechanism. It's compact in size and requires minimal control tubing. Advantages: easier to maintain and reduce leakage problems. This is its silencer used for discharging. Next, I will introduce air end. First, the GHH air end. It features a built-in oil pump, which is driven closely with the air end. It integrated design with the gearbox serves space. Both the first and second stage rotors are coated with ultra-cured plus Teflon, providing mechanical adhesion, resistance to high temperatures up to 300 degrees, preventing airflow degradation and ensure the components are not taxing. The second rotor adopts Char20CR13 stainless steel, which effectively prevents water vapor from corroding the second rotor. The beers are SKF brand, making the compressor air and run more smoothly. A three-way sales system is set to ensure that the compressed air is 100% oil-free. The gear adopts the highest precision grade of the American Gear Association gear quality Agama 13. The oil cooling jacket can also reduce noise while cooling. Next is the DENAIR end. DENAIR end, the gear precision bearings and oil cooling jackets are the same as those of the GHH end. The difference is that both the first and second stage rotors are made of 2CR13 magnesic stainless steel, which has good corrosion resistance, toughness, and stress. The coatings are all ultra-cured super coatings, which have good self-lubricating and high-temperature resistance properties, and an additional oil pump is required. Watering pipe. It effectively eliminates high-frequency vibrations at the exhaust port, ensures the stability of the rear pipeline. When used in conjunction with the downstream muffler, it can effectively reduce noise emissions. The flexible house. Because of its flexibility, it is easier to install and adjust. To connect the two sections of rigid pipe in the system allows a certain degree of displacement, which has a compensating effect and ensures the stability of the connection between the various components of the system. The air cooler. Aluminum plating fine structure. Compressed air intercooler, aftercooler, and lubricating oil are modelized and integrated with a more compact structure. The intercooler plays an interstage cooling role, effectively reduces the intake temperature of the second stage air end. The aftercooler cools the compressed air at the exhaust port, effectively improving the performance of post-processing equipment such as dryers. The oil cooler maintains a constant oil temperature, prevents oil emulsification, and extends the service life of the oil. By the way, our compressor from 14.5 to 19 kilowatts use centrifugal fan, and 110 to 500 kilowatts use X or follow fans. The water cooler, tubular structure, air follows in the tube, water follows in the shell, and the heat exchange plays a cooling role. The inner tube is made of 304 stainless steel, which effectively ensures the cleanliness of the air. The specific heat capacity of water is about 4 times that of air, and the heat exchange efficiency is better. The water-cooled mode of the compressor with the same power is smaller in size and easier to transport. For water-cooled machines, the cooling water tower is required, and the inlet temperature of the cooling water is to be lower than 32 degrees. The air-water separator. The installation location is between the first stage air end and the second stage air end. Highly efficient water removal, maintaining more than 99% of the liquid water separation effect, effectively preventing water vapor corrosion in the second stage air end. Pre-cooler. The installation location is in front of the aftercooler. Only air-cooled compressors have pre-coolers, multi-turbo parallel structure with external heat dissipation fans. The stainless steel pipe design increasing pre-cooler effect. Check valve. Prevent a compressor reversal caused by air backwash during unloading. It's main machine to prolong the life of the air end. Temperature control valve. There are valve plates inside. By utilizing the principle of thermal expansion and contraction, when a certain temperature is reached, the flow is divided to another route for cooling, regulating and balancing the temperature inside the oil system, extending the life of lubricated oil. The diversion block, ensuring even delivery of lubricating oil and adequate lubrication, effectively avoiding the occurrence of high temperature phenomena. Safety valve. Oil-free compressor have 3 safety valves equipped with an opening valve to open and release in case of overpressure. There are 2 on the air circuit and 1 on the oil circuit. It is also known as an oil relief valve. The motto. The motto is new national standard IE3 engine efficiency level, protection level IP55, F level insulation, B level temperature rise assessment, SKF bearings, stable and efficient operation, effectively dust and water resistance, high temperature resistance, lower filter rate. Some famous brands can be used, such as ABB and so on. The motor efficiency grades IE3 or IE4 can be customers. Sensor. Each oil-free screw compressor contains 4 temperature sensors and 3 pressure sensors to monitor the temperature and pressure at each position of the system. The installation locations are respectively located at the oil circuit. There is 1 sensor for measuring oil temperature after the first stage exhaust, before the second stage intake, and after the second stage exhaust. On the oil circuit, there is one sensor for measuring oil pressure after the first stage exhaust and after the second stage exhaust. Controller. The standard controller is the MAM6090 with keyboard and touch screen function, display of exhaust temperature, exhaust pressure, actual operating current, actual input voltage, and other parameters. With RS Line 485 interface, support Modbus RTU protocol to achieve real-time communication function, standard language, Chinese, English, Spanish, Russian, Korean. Other languages can also be customized. Other controllers can also be used, such as Siemens or CMC. Invent. Standard Invent brand is Invent, a listed Chinese enterprise, the second variable frequency command brand in China. Protection level AP20. The interface has a photo indicator light to monitor the operation schedules in real time. Mode of highly flame resistant ABS material. Built-in filter capacitor to effectively prevent interference. And part 6, sharing of customized designs completely. I will introduce our customer's case to you. One of the DENAIR's major advantages is that it can customize dedicated machines for each client according to their specific needs. Nitrogen compressor. For some nitrogen production industries, we can also customize nitrogen compressors. The oil-free screw compressor adopts mechanical seal for nitrogen, which has a lower density than air. It effectively prevents leakage. Next is heavy-duty air filter. For the cement industry or industry with harsh environmental conditions, suitable for harsh environments with a lot of dust. The filter has a large surface area, filters out dust and solid particles larger than about 5 micrometers from the air, preventing premature wear of the screw root. Duplex oil filter. For oil refiners or other critical industries that cannot be shut down for maintenance work, uses 2 3-way ball valves to assemble 2 single-cylinder filters on one base. This ensures that the compressor can be operated continuously without stopping for maintenance, combined with the use of self-cleaning air filters. Reduce losses caused by downtime for maintenance. This is a customer air compressor designed for the chemical plant industry. It is located in Hong Kong. Stainless steel sheet material suitable for highly corrosive working environments can not only prevent water vapor corrosion, but also resist chemical corrosion. The above is all the information about the DENAIR dry oil-free air compressors. Thank you.
Dear distributors, this is Casey. Over the next 30 minutes, I will describe heat recovery solution to you. First, look at this picture. The green trees and grass are so pleasing to the eye, aren't they? Nowadays, industrial activities such as coal burning and natural gas consumption are gradually placing a huge burden on these trees. So today we will be discussing how to reduce this burden on the trees, and this leads us to our main topic, the DENAIR solution for heat recovery. After all, environmental protection isn't just about empty slogans. Technologies like heat recovery can precisely bring environmental benefits. So where does the energy actually come from? Where does the electrical energy come from? And where does it go? What is the relationship between heat recovery and electrical energy? With these four questions in mind, let's begin today's presentation. Solar radiation is the primary source of energy for Earth's surface and atmosphere. Energy is conserved. It is never destroyed, only transferred from one form to another. This diagram illustrates the transformation of energy, including the distribution of solar radiation, energy transfer at the Earth's surface, and the energy balance of the atmosphere. First, let's see solar radiation. 67 units are absorbed directly by the atmosphere. 168 units are absorbed by the Earth's surface. And the remaining 107 units are reflected back into the space. This time 342 equals 67 as 168 as 107. Second, energy transfer at the Earth's surface. The 168 units absorbed by the Earth's surface. At the atmospheric back radiation, 324 units are transferred to the atmosphere through convection, 24 units, latent heat of evaporation, 78 units, and long wave radiation from the Earth's surface, 390 units. So this time, 168 as 324 equals 24 as 78 as 319. Third, the energy balance of atmosphere. The atmosphere absorbs 67 of solar radiation, receives energy from Earth's surface, 24 convections, 78 latent heat evaporation, and 319 surface radiation, which is ultimately released through outgoing long wave radiation, 235, and back radiation, 324. So this time, 67 as 24 as 78 as 319 equals 235 as 324. Let's further analyze the energy conversion. Solar radiation produces light energy, some of which is reflected by the atmosphere and some by the Earth's surface, but most is absorbed by the ground. The ground heats up, generating thermal energy. The ground heats the air, and the warm air rises, converting thermal energy into gravitational potential energy of the air. The movement of air creates wind, and this potential energy is further converted into mechanical energy. Wind power generation then produces electrical energy. Plants, through photosynthesis, convert the light energy into chemical energy stored in organic matter. There is also a portion of energy that already exists on Earth, such as nuclear energy. The commonly used energy sources are summarized in the diagram, and among them, electrical energy is the most widely used. Why is electrical energy so important? And where does it come from? Currently, power generation using fuel oil, coal, and natural gas is a mainstream in the market. However, these three methods all produce carbon dioxide, which pollutes our environment. And this is an issue we need to discuss. Where does our electricity go? The above shows the proportion of global electricity consumption. According to incomplete statistics, primary industrial accounts for 6%. Secondary industrial accounts for 41.5%. Tertiary industrial accounts for 28%. And the last, urban residential electricity consumption accounts for 24.5%. We can clearly see that most of the electricity is consumed by industrial uses. Let's focus on cities with a high proportion of electricity consumption in the secondary industry. Using 1,093 cities worldwide as the research subject. The star symbols represent cities with a relatively large scale of industrialization, and the small black spots represent the intensity of industrialization. We can see that the top three regions in terms of industrialization intensity are Asia, Europe, and North America. Although the star symbols are not particularly dense in Asia. Why is the proportion still so large? This is because Asia is dominated by heavy industries such as steel production. Shifting our focus to China in Asia. In 2025, from January to October, China's total electricity consumption reached 8.6246 times 10 to 12 power kilowatt per hour, with the secondary industrial consuming 5.4781 times 10 to 12 power kilowatt per hour, accounting for approximately 63.5% of the total. Taking a closer look at the city of Shanghai in 2025, from January to October, Shanghai's total electricity consumption reached 2.15 times 10 to 11 power kilowatt per hour, with the secondary industrial consuming 1.075 times 10 to 11 power kilowatt per hour, accounting for approximately 50% of the total. We also searched that most industrial cities account for roughly 50%. Further focusing on the electricity distribution in Shanghai's secondary industry, we can see that air compressors account for 25%. Pumps and fans account for 18% and 7% respectively, and all other electricity consumption combined accounts for 50%. Electricity consumption in the secondary industry is dominated by air compressor products. Therefore, how to utilize this portion of electricity more effectively is our key challenge. Let's look at the cost proportion of a 315 kilowatt air compressor operating for 10 years. Based on actual data, the initial purchase cost and maintenance costs account for only 7% and 5% respectively, while the majority of the expenses are concentrated in the electricity consumption for operating the air compressor. How is the energy transferred inside our air compressor? In an air compressor, what are the input and output energy? Taking a dry type oil-free screw air compressor as an example, the operating conditions are isothermal at 20 degrees and 60% humidity. Assuming input electrical energy is 100 kilowatt and together with 11 kilowatt of internal energy from the air. This part of energy is mainly from the condensation process in which gaseous water turns into liquid water is an exothermic reaction. After compression, the output is 3 kilowatt of radiant energy. You can feel the energy as heat and warmth when you touch it with your hands, just like touching a computer's case. But this energy cannot be recovered. It has already dissipated into atmosphere. 6 kilowatt of internal energy. Because the compression is isothermal, this portion of internal energy remains within the air. 7 kilowatt of heat from the oil. This portion of energy is generated inside the gears and bearings during compression and is carried away by the lubricating oil. 19 kilowatt of heat from the air. During compression, the rise in temperature of the air itself accounts for the largest share of heat, and this heat is removed by the cooler. And 5 kilowatt of other losses, such as transmission losses. Under certain conditions, the internal energy, the oil heat, and air heat can be fully recovered, so the recoverable energy is more than 100 kilowatt. If this heat can be fully utilized, it will save a lot of extra electricity. Please see our recommended solution. This is the PID diagram of our standard water-cooled air compressor. After the first stage of compression, the air temperature rises, then it enters the first stage water cooler for cooling before entering the second stage compressor. After the second stage of compression, the air temperature rises again, and then enters the second stage water-cooled cooler. The water-cooled cooler has water inlet and outlet. With customized to the standard compressor, a wet heat recovery device is connected to fully recover and utilize the thermal energy. The cooler needs to be enlarged to a suitable size for sufficient exchange. And finally, the wet heat recovery device is connected in series at the cooling water outlet to collect heat. This is air compressor side. Now let's look at the cooling water circuit. Typically, our standard water-cooled air compressor requires a cooling water circulation system, which includes a water tank, water pump, and cooling tower. By simply adding a waste heat recovery device to this system, the compressor's output changes from just compressed air to both compressed air and hot water without requiring any additional electricity, providing free hot water. When can we recommend heat recovery solutions to our customers? Hot water is primarily used in industrial and domestic applications. Industrial uses include CIP cleaning, lithium bromide heating, boiler, feed water, and so on. Industrial water has a high usage, high efficiency, so it is the first choice. Domestic applications include household bathing, space heating, drying, and similar applications, canteen cleaning, and so on. Compared with industrial application, the domestic has a moderate usage, moderate efficiency, so it is the second choice. Because purpose determines the solution, usage rate determines efficiency. How exactly can we calculate how much heat can be recovered? Let's take a look at the energy conversion calculating formula. Q equals C times M times delta T divided 3,600. Q represents heat absorbed or released, which unit is kilowatt per hour. C represents specific heat capacity of water, which is a constant value, 4,187. M represents hot water flow rate, which unit is ton. Delta T represents temperature rises, which unit is degrees. And the the unit can also change into cal per hour. H equals Q times 860. H represents total heat energy, which unit is cal per hour. Q represents energy recovery power, which unit is kilowatt per hour. After learning formula, let's see case study. A waste heat recovery unit was installed on one 3,015 kilowatt air compressor inside the station building to capture hot water from the compressor's operating heat. First, calculations of recoverable heat from the air compressor. Air compressor rated power is 315 kilowatt. Quantity is 1 unit. Waste heat recovery efficiency is 85%. It depends on the heat exchanger's efficiency of the heat recovery unit. In this case, the water-cooled model achieves about 85%. Air compressor load factor is 100%. It depends on compressor's loading. In this case, the unit runs at 100% load. So we can calculate total recoverable power from air compressor is 267.75 kilowatt. Convert the unit to 230,265 cal per hour. Calculate by 267.75 times 860. The calculating process is above. So what can all this heat be used for? We can use the heat to supply hot water for people to take shower. 2. Hot water yield and number of users served. Total recoverable waste heat energy we have already get. Then use formula Q equals C times M times delta T divided 3,600. We can calculate hot water production rate, 6.75 ton per hour. Assuming 24-hour daily operation and 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 . 50 liters of hot water per person takes shower per day. Daily hot water production 157.68 tons per day. Number of people supplied 3,153 persons per day. Also, the calculating process is above. 3. Energy saving benefit analysis of air compressor waste heat recovery. Heating water can also be achieved by burning coal or liquefied natural gas. But these fuels produce additional costs. Let's look at the data. To produce the same amount of heat, 41 kilograms of coal are needed per hour, and the combustion produces 123 kilograms of carbon dioxide. It means with coal price at 0.8 yuan per kilogram and assuming 24 hours of use per day for 330 days a year, this would result in an additional cost of approximately 260,000 yuan per year, and the production of nearly 970,000 kilograms of carbon dioxide. And using liquefied petrol gas and natural gas will cost you more. These figures are really amazing. To conclude, if a small tree can absorb 18 kilograms of carbon dioxide per year, only one 315 kilowatt air compressor can save 111,265 trees, greatly reducing the planet's thermal burden of carbon reduction. So which one will you choose? That's all. Thank you very much.